Hi guys, we'll continue with our discussion for this is electromagnetism class. So we go ahead. Yes. Okay, so we are now on chapter 3 of electromagnetism. This is all about integral calculus. We have the line integral, we have the surface integral, the volume integral, and also we'll be discussing here the Dirac delta function. So previously what we discussed was all about the curl, the gradient, and also the divergence. We had a discussion on that, and we also took some examples so that the concepts will be clearly understood. And you're also done with your recent problem set. And by the way, I've received all of your problem set, and I will be recording that. I'll be checking that, and it will be recorded in the most as soon as possible siya at that time. Then I will just let you know, and it will be reflected anyway on the Google Classroom platform. So let's go ahead and discuss this one. I think this is maybe a review to you because you've undergone this or you've undertaken this topic before in your mathematical physics, and you see all these things will just keep on popping up in almost every discussions of physics, especially in electromagnetism. Okay, so we'll have a review on this, and upon completion of this chapter, you should be able to understand the concept of integrals of functions and vector fields over parameterized surfaces and compute them in simple examples. Then you should also be able to recognize the statements of Stokes Theorem and Divergence Theorem, because we'll be discussing that later on, and then understand how they are a generalization of a fundamental theorem of calculus. Then you will be also doing some calculation on divergence and Stokes Theorem in the context of problem solving involving vector functions. So let's talk about this review on integral calculus. Now, a line integral is an expression of the form. Okay, this is a line integral. So you have a vector v dot with dl is given in equation 20 and evaluated from a to b, or from path a to b, where vector v is a vector function and dl is the infinitesimal displacement vector, and the integral is to be carried out along a prescribed path p as shown in this figure. So take note, we have this line integral here, and it follows a curve or a path along this way from A to B. Now the question is, what is the value of the area under this curve, or the integral of this curve evaluated from A to B? Now if the path forms a closed loop, then the integral becomes this. So meaning ani is a closed loop, this one, v dot dl. And to a physicist, the most familiar example of a line integral is the work done by a force. So you've seen this example before. So this is a classic example, or a familiar example of a line integral. So we have a line integral of force dot with dl, and this is your work. Yeah, it's a function of this, given in equation 22. Now ordinarily, this line integral depends critically on the path taken from A to B. But there is a special class of vector functions for which the line integral is independent of the path. Now a force that has this property is called conservative. So we have a conservative force. Okay, so we'll have an example later on wherein there is this kind of a force when you take the integral of that line integral, then the value is constant or is the same whether you integrate or whether you evaluate the integral from a to b from the value of the integral does not depend on the path or along its way, but it is dependent only on the initial and the final point. Now let's take a look at this example. Now we want to calculate the line integral of the function as shown in this figure. So this is b y squared plus 2xy plus 1 from the point a to b, so from a to b. But take note that going from a to b, we have two different paths here to take. Either we take the root of this path, kaning path 1 or path 2. So along the path 1 and 2, this one, what is the value of the closed loop integral or closed loop line integral of this b dot dl for the loop that goes from a to b? Along 1. So kung along 1 ka, you have two regions to take. We have region 1 and then region 2. Or it returns to a along 2. So ano siya? From a to b nga taken path 2. Okay. So let's solve this one. So this is our example. We have this graph here, and then okay, this is the x-axis and this is your y-axis, and this is point 1 and this is point 2, and then this is the 1, then this is 2 here. Okay, so that's it. And then we want to find the integral, the line integral going from path 1. So path 1 is this is path 1 and this is path 2, and our vector function v is equal to this. So this is your vector function. So we have y squared x hat plus 2x y plus 1 y hat, and then we want to find this integral, right? b dot dl for loop 1 and 2, right? Now let's solve this one. So for the solution, okay, the solution for this one, so we first want to identify what is the dl, your infinitesimal displacement. So as always, dl is just dx hat plus dy y hat plus dz hat, right? And then so let's solve first the loop 1. Okay, loop 1. So for loop 1, we have region 1 and then region 2. So for region 1, we have dy, it's a so as you can see, dy and dz is just 0, right? For loop 1, this one, loop 1, x naman na siya. The direction is along the x entirely, so there is no y and z component. Okay. However, it has a value of y equals 1, right? So your y is equal to 1. Constant ang ihang y, right? This is just a straight line. Okay, So now we want to take this one. You want to take v dot dl in this case. So your v is this one. I'm sorry sa saba sa gawas. Okay. 2x y plus 1 y hat, and then dot with ano siya. So dot with your dl. So your dl is just dx hat plus dy. Okay. dx x hat y hat plus dz z hat. Okay. Now what happens next is you take the dot product. So you have y squared dx, right? Y squared dx, but since dy and dz kay 0, so 0 na siya, 0, so we are left with just this, y squared dx, okay? And also, y equals 1, so substitute 1 here, we get 1, so you get integral of dx, okay? Now the limit is from, if you look at the path, from 1 up to 2 ang x, so this is 1, this is 2. Now the answer would now be x evaluated from 1 to 2, right, is just equal to 1. Okay, sa region 1 pa lang na siya. Now let's go to region 2. Okay, region 2. So unsa naman ang naa sa region 2? Region 2 is vertical naman na siya. Take a look at this. Vertical naman na siya. So we have now dx and dz are just equal to 0, right? Okay, and then it has a value of x equals 2 because it's just a vertical line. So vertical line na siya. So ang x niya is constant, which is equal to 2. Now let's do it again. This time taking the integral of v dot dl. So the same process gihapon. So we have y squared x hat plus 2x y plus 1, and we have y hat dot with your dl, which is dx x hat plus dy y hat plus dz z hat. Okay, close na siya nga parenthesis. So we have now, so take note nga ang dx is 0, dz is 0, so we are just left with dy, right? So sa dy na siya. Okay, so continuing, so we are left with this one. So integral of 2x y plus 1 dy. Okay, now the integral is evaluated from 1 up to 2. So 1 up to 2. Okay, so how do we evaluate this? Take note na x equals to 2, tara, x is just equal to 2. So it will just give me, this is 4, right? So this gawas ang 4 kay constant naman na. So we have y plus 1 dy evaluated from 1 to 2. Okay, so if you want to evaluate this integral, so ana naman na siya. So we have 4 evaluate, i-break down na to siya. So we have y squared over 2 evaluated from 1 to 2 plus y 1 evaluated from 1 to 2. So duha ka parts, right? Because y plus 1. So we are just left with, so unsa naman ni siya? So substitute nimo. So we have 4 square, right? 4 square over 2. So that's 2 minus 1/2 plus, so this is just 1. Okay, so you have 4 times 2 minus 1/2, so you have 1 and 1/2, or that's 3/2 plus 1, and 4 times, so 3/2 plus 1, that would mean 2 times 1, 2, this is plus 3, 5/2. This will just give me 10, right? So 10 ang imuhang value sa region 2. Now the total integral, the value of the line integral b dot dl from a to b is just 1 sa region 1 to region 1, and then our region 2 is 10, so that's actually 11. Okay, so this is now your path, the result of your line integral from region from path A, from point A to point B. Okay, now let's take a look at the value of your line integral if we take the path 2. So create another canvas, whiteboard, and then so for the path 2, balik ko itong drawing mo. So for the path 2, let's go back sa kanang problem gihapon, kaning graph. So for path 2, we can now consider that kani siya diagonal naman ni siya, right? So the line here, this is actually a line, a simple line, linear, and that equation is given by that curve is given by this equation, right? Or function y equals x. So therefore, so y equals x na siya. Doing implicit differentiation, so we have dy equals dx. Right? Then we can also conclude from this statement that your dl for this case is just dx hat and dy hat. Wala siya dz kay x and y naman na siya, right? Okay, so we can now take the integral of this. Let's move it here. So the line integral v dot dl, where v is given by this, so we have y squared x hat plus 2x y plus 1 y hat. So enclose everything and then take the dot. So atong dl is just dx and y naman. dx dy lang. Okay, wala na yung dz diha because if you look at this one, this is a straight line and this is in terms of x and y only. Okay, let's take the dot of this. So we have y squared dx plus 2xy plus 1 dy. So that's it. Now the question now is, masa ang iyahang interval? This is from A to B, right? So we can further simplify this one. Take note that we have at the outset of our problem, so we have y equals x. So we can simplify this if we substitute y with x. Okay, so this becomes x squared dx plus 2x. This also becomes x plus 1, right? This is also dx. So mas simplify siya. So adding similar terms, so we have x squared dx plus distribute, so we have 2x squared plus 2x. This is dx. So we have x squared plus 2x, we have 3x squared, right, plus 2x dx, and this is evaluated from 1 up to 2. So ang x nimo, right, x is from 1 up to 2. Okay, so taking the integral of that, this is 3x cubed over 3 evaluated from 1 up to 2 plus 2x squared over 2 from 1 up to 2. So this becomes x cubed naman na siya, right? So you have x cubed from 1 up to 2 plus x squared 1 up to 2. So this becomes 2 cubed. So you have 8 minus 1 plus 4 minus 1. So this becomes 7 plus 3. So this is actually 10. Okay? So 10 imong value sa path 2. Now if you have this closed loop, mo siya nga integral, right? V dot dl. We have from path 1 plus path 2. Ano siya? Path 1 na siya path 2. Back na pud ka sa path 1. So actually, ang path 1 nimo is 11 to, diba? Plus path 2 mali. So for the closed loop integral, we just do this. So for the closed loop integral, let me erase this. So actually, this path 1, then balik man ka, so it should be minus here, right? So we have path 1 minus path 2. So we have 11 minus 10. So it will just give you 1. So this is the value of your closed integral. So this is the overall result. Okay. That's it. So let me go back to my slide. Okay, we already had the result of this one. Let's continue. Now let's take a look at the surface integral. Okay, so a surface integral is an expression of this form. So kaganina we have v dot dl. This time around is your v dot with your area dA, given in equation 23. So where v is again some vector function, and dA is an infinitesimal patch of area with direction perpendicular to the surface as shown. So that's your dA. Perpendicular na siya always to the surface. Now if V describes the flow of a fluid, so fluid is mass per unit area per unit time, then if we have V dot dA, that represents actually the total mass per unit time passing to the surface, aka flux. Right? So ang flux is actually calculate niya kung pila ka buok, the total mass per unit time passing to the surface. So ang surface niya is mas dako ang contribution if your vector function is parallel to the parallel gid kay siya sa imong direction sa imong area, and if your vector function is perpendicular to the direction of the area, kana iyang like this one, if ang vector function is ni perpendicular, it has no contribution. Only those vector function nga mo lusot diha, let's say parallel gid siya ani, right? So iyahan na i-calculate. Now, if the dot product is maximum, therefore parallel siya. But if you have a vector function nga naa siya dinha, so it's not parallel, but naa siya value gihapon if you take the dot, right? The V dot with the area, so naa siya gamay nga value, but mas dako gyud siya maximum if it's parallel. So it's like counting how many number of lines that pass through this unit area. Kaya siya nga area. So let's take a look at an example here. So calculate the surface integral of this vector function over 5 sides. So exclude mo ang bottom of the cubical box. So na siya side nga 2 as shown in this figure. Now you let upward and outward be positive direction. So positive, asa man ang mga positive ani? Upward, this one. And then also the outward positive as indicated by these arrows. So let's calculate. Okay, so this is our problem, by the way. So ako siyang gidrawing diha. And then we are given with a vector function of this form. We have 2xz x hat plus x plus 2 y hat plus y z cube minus 3, okay, z hat. And I also labeled the following regions para mas dali siya. So I have, this is for region 1, this is ang facing ni ang kani siya nga face, right? Then ang kani sa likod, region 2. For the region 3, ang side sa right side and sa left side, region 4. Then upward, the top face, if we have the region 5. So wala na katong bottom, okay? 6. Now if we take the sides one at a time, so let's consider now region 1, right? So for the region 1, okay, so if you take note sa region 1, kani siya nga face, so constant ang ihang x, which is x equals 2. We can just label it here, x equals 2. How about ihang dA, right? The dA or the area is ang kanira man siyang square niya. So we have the area is the length, ano siya? Length times width. So that's actually 2xz, right? And then that's dy dc. I'm sorry, it's rather okay. So ang area niya is kanya naman, di ba? The area of the square. So we have this x, this is y, this is y, and this is z. So therefore the area is just dy dz. And then the direction niya is normal to the plane, which is the direction niya is x hat, right? Ang kani siya, padulong mo na sa x. Now we can now take the v dot dA. So ang v dot dA is just that product ana. So ang dA nimo is just x hat, so therefore i-dot yun mo siya sa x, the rest kay 0 na. So we have 2xz dy dz. Okay, so that's it. And take note that x equals 2, so we substitute x here with 2. We have 4z. So this is 4z dy dz. Then we can now take the integral of v dot dA. So this one, so the integral is just 4. This is your v dot dA. So this is z dy dz, right? This is area. So ato siyang i-break down na yun. We have 4 dy and then z dz. So ano lang. Now the limit sa y, take note sa y, it's from 0 to 2. And ang limit po sa z is the same because it's a box, it's a cube, it's from 0 to 2. Okay, if you integrate this one, this is just 1, right? So ato na lang explicitly show you. So the integral ani is just y evaluated from 0 to 2. Okay, times the integral ana is just z cube. So z square, I mean, over 2 evaluated from 0 to 2, right? So this becomes 4 times 2, whereas kani, so we have 2 squared, that's 4 over 2, right? So this will just give me 4 times 2 times 2, so this is 8 times 2, that's 16. Now let's move on sa region 2. Region 2 is katong sa likod, okay? Sa likod siya. You can notice nga ang x niya is 0, right? So wala na siya x, naman siya sa origin. X equals 0. However, ang iyang dA is still the same. You have dy dz, but the direction now is opposite, right? So instead na sa positive x direction, na naman siya din eh. So negative x direction. So this becomes negative dy, still dy dz ang iyang. So this is y and then z. So that's the area, length times width. So dy dz, negative x hat na siya. Okay? So we are on the right track. Then we can also, then we do this v dot dA, right? So ang dA nimo is kani, and then ang v nimo is kana. So we just have to multiply the x part only. So the same gihapon na siya, but this time this is negative because of the direction of the unit vector of the area. So we have 2 xz dy dz, but since x here is just 0, so this will just give me 0, right? Therefore the v dot dA is just 0. So wala na siya value. Okay, and then let's move on sa region 3. So take a look at the region 3. This time around, na siya value, na siya sa, na-situate siya sa y equals 2, right? As you can see here. So y equals 2. How about the area? So positive in direction. The area now is dx dz, right? So dx dz, but the direction is positive y hat. So we can now take the dot product of the vector function and the dA. So we can multiply na nato ang y hat o y component. So this is just x plus 2 dx dz. So that, so add ta p dot dA, and then evaluated from 0 to 2. So we have x plus 2 dx. Sa mabulag na to ang x and the z component. So this is z evaluated from 0 to 2. So if we evaluate the integral of this, so may mo na siyang x squared over 2 plus 2x evaluated from 0 to 2 times just the z from 0 to 2. So mahitabuan ni this becomes 4 divided by 2, just 2 plus 2 times 2, so you have 4. So this is 4 plus 2, then we have 6 times, this is just 2, so it will just give me 12. Okay, sakto na siya. So 12 na siya. Now for the region 4, I think maigo lang siguro din eh. Oops. Hindi ko kasuwat. So, region 4 na lang. So, kaya siya. For region 4, if you take a look at region 4, so naan naman siya sa origin, right? So this becomes y equals 0. And then the area is now negative of dx dz. Okay? So diretso na lang ta. So we have integral. So we have v dot a. So ang y component rin mong i-multiply. So we get this. But since negative man na siyang direction, so we have negative x plus 2 dx dy, right? Dx dz, I mean dx dz. Okay, so kana take note nga wala naman na siya contribution because wala man tayo masubstitute diha, it's just function of x. So take note, ang pag-evaluate and it's just the same here sa kaning 3 bitaw. So I don't have to redo the calculation because we already did it. The same naman siya ang result sa region 3. Such a way na lang siya negative sign. So this is now negative 12. Okay? So how about for region 5? So region 5, kaning taas mo na siya. Okay, kaning atop. So this is now z equals 2, and then take note of my dA it is now dx dy, right? Dx dy, but the direction is along the z, perpendicular siya sa surface z hat. So if I do the integral, so v dot dA, v dot dA, so sa z hat lang ka nga magtanaw, so this is your z hat sa v, so this becomes y z cubed minus 3 dx dy. Okay, but since z is just equal to 2, substitute mo siya diha, so 2 cubed, that's 8. Okay, 8, so 8 minus, so this is 8 minus 3. Oh, is this cube? Let me take a look sa ito ang problem, example. I think I made a mistake here. This is square. Okay, let's go back. So this is not cube, that is actually square. Really, that is. Okay. Wala. So this is actually square. So this is also square. Okay, square. So substituting z equals 2, we get 4 minus 3, that's 1. So actually, mahimot na siyang, so 1 na siya, malik sa, wala na i-erase para mas simplify. So this becomes y, right? So y na lang siya. We have dx dy. So mas simplify na siya. And evaluated na siya. So ato na siyang, this is area. So ato siyang ibuwag. So we have x y dy from 0 to 2. From 0 to 2. So duha na siya kay, this is a double integral because this is area. So may tabuan na, this becomes kani, right? This is actually dx. So dx, this is x, evaluate mo, this becomes 2 times, this is y square over 2. So y square over 2 so y square over 2 evaluated from 0 to 2. So this is 4, right? 4 divided by 2 is just 2. So 2 times 2, this is now 4, right? Now, we already had this one. So evidently the total flux, ito lang ibutang din. So the total flux now is just the sum of the individual parts. The surface. So this is just, so good, we have 16, region 1, 16, region 2 is 0, region 3 is 12, region 4 is negative 12, and then region 5 is 4. So if we sum all that, the total flux is just 20. Okay, so that would be our final answer. So I'll just box this product. Data. So actually the total flux of this vector function, this vector function dot with this kani siyang box area. Okay, so this would mean this is the value now of the total number of lines that passes through the surface of this figure, this shape. Okay, let's continue. Okay. Now let's take a look at volume integrals. So a volume integral is an expression of this form. It's just the integral of some vector function t d tau. D tau is your volume element given in equation 24. So where t is a scalar function, okay, and d tau is an infinitesimal volume element. So in Cartesian coordinates given by this, d tau is just dx dy dz. If t is the density of a substance, then the volume integral would give you the total mass of such that. Okay. So if you have this one, your v is given by this vector function, vx and so on, d tau, or x hat is just this given by this expression. Okay, and because the unit vectors are constant, so they would come outside the evaluation of the integral. So sometimes we encounter these volume integrals nga it's a vector function, but most of the time it's just this is a scalar function. Let's take a look at this example. So we want to calculate the volume integral of this scalar function t equals xyz square over the prism shown in this figure. Now let's solve this one. Okay, so this is the problem. We are asked to evaluate the volume integral of this function over a prism. Okay, so kani mo siya ang prism, dina siya kaninga dimension. So x from 0 to 1, kani siya 0 to 1, and z is from 0 to 3. Okay, so evaluating the integral, so ano naman na siya. So this is volume, and this is t d tau, right? So this is just volume x y z square dx dy dz. Now, taking apart here is we can actually take the integral of the x in terms of x, y, and z separately. But the question now is, unsay limit sa imuhang x, sa imong y, o sa imong z? Because actually it looks like this. You have x dx, you have y dy, and then z squared dz. Okay, so inana ang mahitabo. So actually we can take the order lahi ang order, pwede it doesn't matter kung asa unahon, pero masayon siya if we do this. Z squared dz, we have y dy, x dx. Okay, so we can actually take unsa nga kuan ana nga order. It's like unahon nimo og evaluate ang x, tapos ang x magamit nimo siya sa y na pod, and then sa y you get now the z. Okay, so unsa may limit dai na to if you evaluate this first. Okay, limit sa x. Okay, so kani siya. So it's not as simple as it may seem, because if take a look, ato ni siyang i-drawing ha balik nasa x and y lang a plane. Okay, so this is x, this is y, and kana siya nga line. So unsa man siya nga line? Okay? Unsa may equation ani nga line? So to get the equation of line, say naman na, right? Na sa inyong high school na siya nga concept. This is 1, this is 1. So to get the line, you have to get this form, y equals mx plus b. So we need to get the slope and the y-intercept. To get the slope, we get this y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Say this is 0.1 and this is 0.2. Okay, so ang 0.2 nimo is y sub 2 is just 0, right? Then ang y sub 1, this is 1. Then x sub 2, so your x is 1 minus x nimo ana is 0, right? So the slope actually is negative 1. Now we want to get the y-intercept. Let's choose this point. So kaning point is 0, 1. So we have 1 ang y, negative 1 ang imong slope. So x is 0 plus b. We get this, right? At ang gigamit nga xy diha is kani siya 0, 1. So this is 1, this is 0. So you get 1 equals b. So y-intercept equals b. Therefore, the equation, kani nga equation is just y equals negative x plus 1, right? Or this is just 1 minus x. So na siyang equation. Okay? So the limit now here, is just from, so the limit there is from kana siya, from 0 up to this one in terms sa x pa na siya, in terms sa x. So ako na siyang i-convert. So y equals 1 minus x. X is therefore transpose. You have 1 minus y. So this is from 0 to 1 minus y, right? Okay, so let's continue. Ano siya? So this becomes z squared dz y dy. So if you evaluate na nimo siya, this becomes, have x squared over 2 evaluated from 0 to 1 minus y. So the reason why nani ang iyang exponent o iyang evaluation point, because ang result ano niya is magamit nimo siya dayon diri sa next step, which is in terms of y na siya. Okay, so let's evaluate that one. So that will actually become, so this is 1 minus y squared over 2, right? 1 minus y squared over 2. Or, gawas na siya ang 1/2. So we have c squared dz. Then we have y, 1 minus y squared. This is dy. Okay. dy. Okay, ito alam na siyang i-distribute dayan, guys, in class. So we have c squared dz. So this is y times, gawas na ko ang 1/2. So this is 1 minus 2y plus y squared dy. So medyo taas na siya. 1/2 z squared dz. So we have y minus 2y squared plus y cubed dy. Okay, So the limit here is from 0 to 1. This is from 0 to 3. Okay. So ako siyang ipadayon ko dito. So this we have 1/2 integral. I can just take the integral of this. This is just z cubed over 3 from 0 to 3. Now how about this one, the y part? So this is y squared over 2 minus 2y cubed over 3 plus y to the 4th over 4. This is evaluated from 0 to 1. Okay, so this is now 1/2. So this is 3, right? So 3 cubed, that's 9, and then 9 over 3, so that's 3. How about this 1? So this is 1/2 minus 2/3 plus 1/4. So what do I get? We have 3/2 times. So LCD niya is just 12. So this is 6 minus 12 divided by 3. That's 4 times 2, 8 plus 12 divided by 2. That's 3. So we have 3/2. 6 minus 8, that's negative 2. Negative 2 plus 3, that's 1 over 12. Okay, so it's 3/2. So cancel this. Yeah, this becomes 4. So I have 1 over 8. Let me check. Okay, I made a mistake somewhere here. So pag evaluate na ako, we have 3 cubed. So 3 cubed actually it's 27. So 27 divided by 3, this is 9. I'm sorry about that. This is 9. So this is 9. So this is 9. What will happen is 4. So this is 3. Right? So this is actually 3 over 8. So muna siya ang answer. So that's 3 over 8. Okay? So that's for the volume integral. Now let's proceed to this one. Okay. So we calculated this problem, or we've solved this problem already. So this is 3 over 8. Now let's move on to the theorem of the divergence theorem. So the divergence theorem states that, given in equation 27. So I think naka-encounter na po mo ano before sa inyong mathematical physics. So in other words, the integral of a derivative over a region is equal to the value of the function at the boundary. So at the boundary. Okay? So an analogy might be helpful to completely grasp this crucial concept. So it's like this. So this is the faucets within the volume. Okay, finish up. This is the faucets within the volume. The volume is just equal to the flow out to the surface. So kung unsa man gani ang tubig na mo gikan sa imong faucet, mo pud ang gawas dito sa surface, right? So it's just conservation. Actually, equal siya dapat. So we can check this theorem. Can you see it? equation 27, we can check the divergence theorem using this function. So let's take a look at this function. And a unit cube situated at the origin. Okay, so the same niya ko na siya kanina. Then we just have to take the divergence of this entity, of this vector function, and a unit cube situated at this. So let's try to solve. So this is our problem. We want to check the divergence theorem based on this given vector function, and the cube here. This is the same cube that we had in our previous example. Okay. So in this case, so on divergence, if you recall the divergence theorem, so this is the divergence theorem. We have the volume here, and then del dot v tau is equal to this closed surface integral v dot dA. And that's the volume integral. Okay, the divergence theorem. Now let's try to calculate this first. So del dot v. So for del dot v is just the vector function is just this one, dx. Okay, so for the del dot v is just 2 times x plus y. Wait, we'll have any color. Oh. Okay, for this case, balik ta sa atong let's try to calculate this first. We have del, okay, let's just use blue. So the del dot v is just derivative naman to, diba, sa kani. So derivative niya is just 2y plus with respect to x is just 0, and this is with this is, let me see the problem first. That's y hat. Okay, made a mistake. So this is so y hat na siya diha. Okay, just black. So that's y hat. Okay, let's continue. So actually kung imo siyang i-write, diba, inana mo na siya, dx x hat plus y hat plus z hat, then dot with the vector function y squared x hat plus 2xy plus z squared y hat plus 2yz hat, diba, ana man na siya. So we have derivative with respect to x, so 0 na siya. With respect to y, so this becomes 2x only, and then derivative with respect to z, so that's 2y, so plus 2y, and So therefore, this is just 2x plus y. Tama? And we then substitute kana siya diha, so that we have the volume here 2x plus y d tau. So this is just 2. So triple integral na siya. And this is from 0 to 1, 0 to 1, 0 to 1. So this is x plus y dx dy dz. So this becomes so evaluate mo una ang x. So kana, so this is dy dz from 0 to 1. Then evaluate mo siya ang x. So we have x squared over 2 plus yx evaluated from 0 to 1. So that would become, so dz lang na siya diha. So dy. So this becomes 1/2 plus y, right? So that's 1/2 plus y dy. So kana na po na nga ito ang i-evaluate. So this becomes 2 dz from 0 to 1. So evaluate this one, evaluate the integral with respect to y. So this becomes 1/2 y plus y squared over 2. And then this is evaluated from 0 to 1. Okay, so evaluate mo siya from 0 to 1. So this becomes 1/2 plus 1/2, right? So that becomes, this becomes 1. So that's actually 2 dz, just integral of dz from 0 to 1. So this is now 2 z from 0 to 1. So this is just 2. Okay? Therefore, the left hand side, this one, this is just equal to 2. Okay. So to prove this theorem, the divergence theorem, then we have to show that the surface integral, the closed integral of this one is also equal to 2. So isam nimo siya, right? So imura man siyang buhaton nimo is we take the divergent, the dot product of vector function and then the dA sa kaning region 1, sa region 2, region 3, region 4, then i-add mo tanan, and that should equate to 2. So for that case, for that exercise, I will leave that to you. So inyuhan, it's actually naasa inyuhan, I'll leave that to you, and then you try to solve it, and then you upload your answer, i-picture ninyo siya, i-upload ninyo sa Google Stream. Okay? Tapos you can really see na ma-proven gina siya, this one. This is 2, so this must be equal to 2 para ma-satisfy na siya nga, para ma-satisfy na siya. This one, this is your divergence theorem. This is your faucet, ang source, and this is the flow out to the surface. Kani siya, surface. This is the source, this is the flow out to the surface. Okay. Now let's move on to the Stokes Theorem. So kanina is the divergence theorem. Now for the Stokes Theorem, it states that the integral or the surface integral of the del cross v dot with dA is equal to the line integral of the vector function v dot with dl given in equation 30. So del cross v dot dA depends only on the boundary, because this is the depends on the boundary line, not on the particular surface used. Okay. So this entity here is equal to 0 for any closed surface, since the boundary line, like the mouth of the balloon, shrinks to a point. Kung i-shrink mo ang balloon, becomes a point. So ang iyang surface integral is just 0. Okay. And hence the right side of the Stokes equation vanishes. So 0 po na siya. So let's take a look at this example. We have b given by this function equation. So you check the Stokes theorem for the square surface of the same gap. Check naman ang Stokes theorem. Okay. It could be so dA could either be in counter or counterclockwise. Now for this case, consider na to ang counterclockwise lang. Since x equals 0 for the surface, wala siya x, right? Because naman siya sa kaning YZ plane. Okay, so you just have to perform this one. I'll just leave that to you, del cross v, and then you get this one, and then substitute x equals 0, you can actually get this. Okay, and is equal to 4/3. Okay, so ang detail anak amo na lay bahala anak. The vector function is given by this, and then the dA is given by this, so it's just dy dz. Okay, so it's dy dz na siya ang a. Then you get the curve using basket method. You get some answer here, then substitute mo ang x equals 0, so you get this. Okay, that's for the left hand side. Okay, for the right hand side, mo siyang i-sum gid mo siya the line integral. Okay, so we have region 1, region 2, region 3, and then region 4, so part 4. Okay, so for the part 1, so we have okay, for the part 1, x equals 0, z equals 0, right? Tara. Kani siya nga line. Wala siya x, wala po siya z. It's just purely y. Okay? So you can actually check sa inyong paper. Have your vector function v with that with the dl, you get this, and then you can check this on your own. And if you add this one, you add all of these, you can actually get 4/3. So that proves the curls, the Stokes theorem. Okay, so 4/3 man to ang left hand side. So the left hand side is 4/3. So ito akong so the left hand side is this is so this is actually 4/3. Kani po 4/3 po na siya. Okay, so that proves the Stokes theorem. So yun na siyang mano-mano gina siya o kuan. It checks. Then Another useful mathematical tool that I guess you already know this one is the integration by parts. Okay, so integration by part techniques, I will skip that because you already know this one. So if you take a look at this example, x e to the negative x, we can evaluate this integral easily by employing the concept of integration by parts. Okay, I'll just leave that to you. Okay. That's all for this session. Next week we'll continue on vector analysis on curvilinear coordinates, specifically on spherical polar coordinates and in the cylindrical polar coordinates. See you next time.